We're going to take a look at numbers 26 through 30, dealing with simple machines and specifically the screw on activity 112 simple machines practice problems. In this scenario, we've got a 7/16 nut driver with a 1.5 inch diameter handle used to install a 1/4 inch 20 UNC bolt into a robotic arm. So drawing this, a nut driver, it's going to have a little handle here. And it kind of has this little scenario going on. And the 7/16 portion is dealing with this size. Up here at the top, this is 1.5 inch diameter. So as we go along for the handle, and we are going to be putting in a little screw here. Something like that. And this one here is going to have a 1/4 -20 UNC screw thread designation. So 1/4 inch diameter, 20 threads per inch, and unified coarse thread on the type of threading that's being put onto this, or that has been manufactured for the screw. So here's the thing. It says determine the circumference where the effort is applied. Well, whenever you go through and utilize one of these, they give you this value here to kind of throw you off. Where you're really putting your effort, where you put your hand at to turn the screwdriver, is right up here at this portion, this larger portion right there. That's where the handle is. So circumference is equal to pi times diameter. Circumference is equal to pi times, and here we'll use 1.5 to go along with that. I'm going to put 1.50 in there just for just to go through and add another little significant figure in there. And I can go ahead now and take a look at what I've got with my calculator. Pi times 1.5. It's going to give me, here we're going to do again about 3 significant figures just to match what I've got. So we're going to go to 4.71. So the circumference, 4.71, will be the value that I have, inches, so for my units. And then I can go ahead and start taking a look at the rest of some of my problems that I have going on and that I'm going through and dealing with. So the one thing is they want us to determine the pitch of the screw. So the pitch, if we check our formula sheet, is noted as being 1 over the TPI, or the TPI means threads per inch. And where we're going to find that information is right here in the thread note that we have for the screw. So again, the 1/4 is the diameter, the 20 is how many threads per inch. So that means I'm going to put 20 on the bottom, and then I can go ahead and just divide those two to find out what my pitch is. So 1 divided by 20 is going to be 0.05 for that pitch as far as what we have going on there. Okay, and of course this is also going to be in inches. Alrighty, so our next problem here is going to have us finding what is the, and as I scoot down here, what is the mechanical advantage of the system? So as we go along here, we've got a circumference, we have a pitch, screw, IMA. They do not go through and specify which type of mechanical advantage they want. They just want to know what's the mechanical advantage. And again, in these problems, we're assuming AMA and IMA are equal to each other. So in the IMA, we can go ahead and put in our values of 4.71 divided by the pitch of 0.05. And when I do so, to find out what that is going to equal, I get 94.2 for my IMA. 94.2 to 1. So very high mechanical advantage to allow us to go through and overcome a lot of the resistance and everything that we have. So one last problem. ideally, how much force can be overcome if we have 5 pounds of force is exerted? So how much force can be overcome, meaning how much resistance? So I'm going to go ahead and use an AMA formula for this one. Resistance force over effort. And here, AMA and the last one, again, AMA and IMA in this scenario, if we're ignoring friction, are the same. So I'm going to plug in 94.2. I'm looking for the resistance force because they want us to know, or they want us to see, if we put 5 pounds of effort force, how much can we go through and overcome. So again, just multiply times 5, 94.2 times 5. It's going to give us 471. That means we're able to overcome 471 pounds of resistance force if we go through and utilize this particular setup for a screw, as well as applying 5 pounds of effort. This finishes up the simple machines practice problems. So if you have questions or anything, make sure to let me know. But this is done, and we can go ahead and start looking at some of the other items like gears, pulley drives, as well as chain and sprocket systems, to see what are all the different mechanical devices we can have in various machines.